Hi, welcome to Civil Connection channel. If you are watching the videos continuously and haven't subscribed, subscribe it and press the bell button. So when I upload the videos, you may get the notification and you can enjoy watching it. Next it is spec. So what is meant by spec? It is that if it is a secondary beam, we need to consider, we need to we need to release the moment. If it is an elastic beam, you need to release the moment or shear or forces, whatever may be, what is the forces acting in the beam, you need to release it or something. Okay, so that is considered in the specification. Here I have been considering a secondary beam here. So in secondary beam, the forces only will be getting transferred to the other beams, which is supporting the, which is supported in the main beam. Okay, so if I consider this if I consider as a secondary beam, it will be transferring only the forces, so I need to release the moment in the sections. So for that I need to consider what is the starting point and what is the ending point. So here if I consider this is, because column is in one side and other side it is, we shall check it here, I shall show in the top view. In the top view, in this beam, the both ends are considered as a it is supported in the beam. But when you consider this beam, here you have a column, in this point you have a column, and this point there is no column, and when you consider here it is a column. So you need to find where is the starting point and ending point, because if you need to release the moment in one side of the beam. Okay, so what is the starting point and what is the ending point, you need to check it. So that press shift E. So it is green color shows the starting and blue color shows the ending point of the beam. Okay, for each and every beam there will be starting point and ending point. So here what I have modeled in the bottom will be same as in the top. So that is starting point is in left side and right side it is the ending point. Okay, that is the starting point and ending point. With the starting point and ending point only you need to consider, you need to model, you need to release the moment. Here I have the moment, I have the in area section you can see there is edit, delete, node and beam. In node you can see you need to release the moment. If it is a that is a slave moment, that is slave node means we will be transferring the load to that node. Okay, but the load will, the node will not be connected to the structure. Example, if we consider a column with this axial loaded, the load will be transferred, you need to transfer into pressure. Okay, the load will be transferred as a pressure, but the load, it is a point load. So how will you transfer this point load? So it will be considered as a center point. You cannot consider the center point of the column to transfer the load. So you need to create a node above the structure and you need to transfer the load to the node, and that node to be connected rigidly to that surrounding all the other nodes in the column. Okay, that is similar to a finite element analysis. Okay, so that the load will be transferred from the point, that is node, which is placed above the column, to from that node you need to transfer to the column. Okay, we shall see, consider regarding this in the some other project. Okay, so this is noded project, noded specifications. And in beam, here there are number of specifications. So first here member release is there. Member release, it is partially moment release or full release. Then offset of this, how it is, that is you need to be carrying the load which is somewhat offset from the, that is some beams will not be perfectly axial to the column. So it will be some offset will be that is considered here. Then property reduction factors, cable or truss, then fireproof, imperfection, inactive, tension, compression. These are some of the specifications. So in this project we are going to use about the release. Okay, here I shall take the top view. Before that I shall say how it is moment is released. Okay, here I have modeled this secondary beam in x direction. When I have modeled this in x direction, I need to release I need to release in the Z direction. Okay, here I don't want that is there will be not be any force will be transferred here, so there will not be any release in the force. You need to consider only the MZ in start as well as in the end. You need to edit, you can edit it. Okay, edit. If it is start, there not be. So I shall create another thing, and there will be a start and also a end. So because one beam will be starting and other beam I will be releasing at the end. So I have considered here, I shall consider in the top view, and here in this beam, in these two beams need to release in the end. So end M is assigned to selected beams, and here it is at the start. So I shall assign here for the start. So after releasing here, you can check it here. This is the dots. It will be considering the start and end of this beam. Here I have modeled in the Z direction, so I need to release in the X direction. Okay, so beam again MX at the start as well as another beam MX at the end. Okay, now I shall release both in this beam, assign to selected beams. So I have released. After, if it is released or not, it can be checked through this ring. Okay, now it is released. I shall so you have seen about the specification, how we need to release the moment. Okay, now you can see the support section. So you can I know that what is the start and the end I have checked. Now we shall remove this where is the beam starting and ending. Okay, by again pressing Shift E. Now move to the support section. So what is the support you need to provide for the building? You need to provide only the fixed support at the bottom, because it is placed under the ground, that is below the ground level for 1 meter or 1.5 meter. So if it is provided or below the ground, it is firmly fixed by the hot strata. Okay, it is firmly fixed in the hot strata, and above that we are filling the footing with the earth fill. So the load will be transferred to the hot strata. Okay, this will be acting as a retaining structure. So it is both sides, whole sides will be filled with the soil. So it is submerged in the soil. Okay, so it will be firmly fixed. So the stability will be higher. So you need to create the support as fixed. Okay, I have created the support as fixed. Now I shall choose the front elevation, and bottom of the section will be selected, that is with the nodes. I shall select with the node cursor and assign to the bottom nodes. Okay, so this is the I have given the support section. Now we need to go for load definition. Here load definition usually we shall create for a structure, that is dead load, live load, wind load we shall be modeling, and then again earthquake load. So in this structure I shall explain about the dead load and the live load, and wind load will be considered as a separate part, and earthquake load will be considered as a separate part. Okay, so for that I have been saying that here we shall follow as per IS 875. Here I shall create the load case details. For that I need to add load case detail. Here primary it is considered, here it is dead load. So dead load it is load case 1. So change into DL, that is dead load I have changed. I have added this, and I need to again add the live load. Here it is LL. You should not take this value, that is recursable of UBC or IBC, because it is of American standard. So it will not be considered here. Add. So these two are considered. So I shall consider the load combination. Define load combination, it is that we need to define the combination, or you can consider the auto load combination. If it is auto load combination, you need to select the table. Indian code, it is a general structure. If it is a general structure, you need to consider as a general structure and generate loads. So there will be number of loads as per code, Indian code. Okay, so they have considered 0.9 times the dead load, 1.5 times the dead load, and other they have considered 1.2 times dead load plus 1.2 times live load. Similarly, 1.5 times dead load and 1.5 times live load. Okay, so you can consider there is a maximum load combination. It is 1.5 times dead load plus 1.5 times live load. So I shall consider here as I shall model it as dead load plus live load. Here it is given default. Okay, in this default you shall consider 1.5 and change this dead load. So here the factor becomes 1.5. Okay, so and give it as add. So you have added both load case details. Okay, if you open here the STAAD editor, here you haven't given any load. Okay, I shall give the load and then I shall open and show what is the STAAD editor it is being used. Okay, now I shall show here how the dead load is added. So in dead load, what is meant by dead load? Dead load, it is nothing but the self weight alone will be the dead load. Here I haven't explained one thing. I haven't modeled the slab. Why I haven't modeled the slab means, if I have if I have modeled the slab, it will be considered in the neutral axis of the beam. But in practical, we used to put the slab above the beam so that the beam will be transferring the load to the beam and the beam will transfer the load to the column and the column will transfer to the footing. This is the concept, but as per our consideration, when we model in the STAAD Pro, if we model the slab, it will not transfer the load clearly and will not be considered clearly. That is, design will not be clear. So we can neglect this slab design in this part. Instead, you can model the slab in a separate portion and then you can you can check the shear values, moment in the structure, that is shear values, that is you need to check the bond mass stresses as a plate analysis. So if you design as a plate analysis, you cannot find the reinforcement details in that section. Okay, because we are going to analyze using a finite element analysis. Okay, this is the concept here we are going to consider here. Don't model the slab with the framed structure. If you model, there will be some errors in the results. That is not in STAAD Pro, but when you design it, I think it is a fatal error in the design. Okay. Now, for dead load, I shall consider only the self weight. So dead load, I shall select the dead load in the data area and add it. Here I will be having a dialog box. So with the dialog box, you need to add the self weight. Self weight will be considered gravity to earth. Gravity is perpendicular to the earth. So it is in y direction. It is minus factor. It is -1 because it is acting in the opposite to the axis y. So -1 I have added here. Then close. So the self weight should be added for the whole structure. So you need to select and give assign to view. Okay, I will be giving assign to view and select it. Okay, now I shall add one more load for live load. This is I shall show what is the difference between what the factal error we are creating here. Okay, in live load we usually consider that what is live load, that is a floor load will be considered as the live load. Okay, and the slab load should be considered as a live load. Okay, how we are making the mistakes, we shall say here. Usually we shall put the live load, that is live load will be acting in the floor, that is the slab, above the slab. We shall consider as 2 kilonewton per meter square will be the load. That is 2 to 5. That is depends upon the working area. Maybe kitchen, storeroom will be storing lot of things in the kitchen or storeroom. And in staircase, if the traveling, if the persons moving in the stair is higher, then that will be considered as that will be given 5 kilonewton per meter square as a live load. Similarly, it depends upon the place what we are using. Okay, if it is if you are considering a building that is a assembly building, the live load will be higher. When you consider the building which does not consider any assemblies, that is many members will not assemble in a place, then the place will be having a live load of very less, that is 2 kilonewton per meter square is the minimum. So we shall consider that. Okay, so I shall show how we are going to apply the floor load and whether it is necessary or not. Okay, here you have a floor load. The dialog box, you have a floor load. Just it is in Y range. Okay, Y range, it starts from this is 0. This is 0, and here it is 3.15. So I shall change the Y range as 3.15. Okay, the pressure, it is -2. It is acting downwards, so it is -2. I shall put it and give the add. Now we shall see, here it is given as floor load, it is transferred like this. Okay, we usually have said that the dead load of the, that is, it will be acting above the slab and the slab will transfer this load. But here we have in modeled the slab, that is the first concept. And the second concept, here see this load, that is, it is a formation of load distribution, that is load distribution pattern. It depends upon the load distribution pattern. That is correct. This option, it is right. The load will be transferred based on load distribution factors. Okay, that is crack pattern. Depends upon the crack pattern of the slab. Yield line theory. Yield line theory, we may have studied about yield line theory. In yield line theory, the load will be transferred for trapezoidal and triangle in rectangular slab, and 4 triangles in the square slab. That is the concept we are studying in yield line theory. Here, see at the ends of the beam, why it is considered as a triangular load, and here why it is considered as a trapezoidal load. What is the use? That is the this concept is wrong. Okay, so if we transfer in this pattern, the load will be maximum at the middle and will not be considered loads equally in this beam. So in order to consider this as a uniformly distributed load, we need to calculate the area of this member, and you need to consider this as an UDL load. We need to convert this to an UDL load, and then you need to follow this. Okay, so I shall for that I shall give a load. Okay, here add, I shall add a member load, that is uniform force UDL 1 kilonewton. Okay, to a beam. I shall explain why I am adding this in the next part of this video. Okay, just I have added. Now you see the STAAD editor. What are the formation it is formed here? Okay, so you need to read the STAAD editor also then and there, so that we can find the errors if we have committed next at other portions. So you see here, STAAD I have modeled in space. I have imported from a DXF file. That name is drawing 1. Okay, the start job information, engineer date, job with input width, then input units, then coordinates. What are the coordinates? It is given here. Okay, from that STAAD editor, this is all the coordinates. Then member indices. Member indices means we need to connect the form a beam or a column. Then define material. So material I have chosen concrete material. It has a Poisson's ratio 0.17. It has an Young's modulus of 2.17 into 10 power 7 Newton per mm square. Density it is 23.556. Alpha means it is expansion coefficient. Expansion coefficient 1 into 10 power minus 5. This is damping ratio. Damping ratio, it is used for earthquake calculation. That is earthquake. If you have given earthquake load, it will be considered. Then type, it is a concrete. Then strength, that is cubic cylinder strength. Okay, FCU, it is 27. Here 27 means it is 25 Newton per mm square. 30 Newton per mm square. It is the compressive strength. So define material property, it has been over. Then material property, what are the values given for material property? That is column I have given 0.3 cross 0.3. So what are the beams? That is what are the sections? That is a column. This is for beams. So these are the number of that is the number for beams. It is the for beams. Then secondary beam I have added 2 beams. So it is 28 and 88, or secondary beam I have given this dimension 0.15 cross 0.23. So constants, it is over. Then I have given member release. What are the member release I have given? Then supports. These are the supports I have given. Then member load I have given, that is self-height I have given for type 1, that is dead load I have given self-height, and for live load I have given this member 78. It is given uniformly distributed load. So UNI, it is acting in GY direction, that is global Y direction. It has a value of, I have given the load for -1. Okay, this is member load. This is a member load, so it is given member load. Okay, then load combination we have given. So load comb 3, that is the third load, that is dead load plus live load. I have given the name dead load plus live load, and the factor it is 1, 1.5, 2, 2.5. That is first combination, first load. Load 1, it is 1.5 factor. This load 2, 1.5 factor. This is the STAAD editor concept. Okay, you should know about this. And then last finish. Okay. Thank you. We shall see remaining in the next part. Thanks for watching the channel. If you like, press the thumbs up button. If you haven't subscribed it, subscribe it. You can share with the friends. And if you have any comments regarding the video, you can comment it in the comment section. Thank you.